Hi everyone, welcome to the video. We are going to solve play with OR, and this is bitwise OR. Okay, so it does not look at the overall number, but it applies the OR operation on the binary representation of a particular number. Cool. So that is why, okay, see, we are given an array of length n, and we have to apply bitwise OR for all the array elements. For current index I, we have to do bitwise operation between current I and I plus 1, index I and I plus 1. Okay, if for some I plus 1 does not exist, then do not change it, which means if we are given odd length array, in that case we do not have to consider the last element. We will return it as it is. Cool. Now, how it is different from normal array, let me tell you. See, for the array example 1, bitwise or between 10 and 11 is 11, because if you represent the 10 and 11 in the binary representation, okay, there will be last element, rightmost element will be 1. Okay, and that is why it became 11. But forget about these index. Look at these index 2 and index 3. The numbers are 1 and 2. Numbers are 1 and 2, but their binary representation is 3. How come? Because what is the binary representation of 1? It is 1, and 2, it is 1 0. If you apply bitwise OR operation between 0 1 and 1 0, you will get 1 1, and 1 1 is 3. That is how you get 3. So I hope you understand it. What is binary bitwise operator? It is different than normal OR operator. Okay, so first of all, I'll create an variable to store the length of the array. Then I will traverse the entire array, but up till n minus 1, because for any index I, we have to apply bitwise OR operation between index I, current I, and I plus 1, one index ahead of us. At the end, we need to return it, and mind that we have to do every operation in place, which means we do not have to construct any new array. We have to change the input array only. So as you can see, it does the job pretty effortlessly and in very less time. I hope you learned a new concept and enjoyed it. Thank you. Have a nice day.